So today, I'm going to be talking about automation as it relates to the practice of architecture. So as you mentioned, my name is Eldridge. So I used to be an architect. I worked as an architect at WDG Architects in DC, and then I became a BIM manager at SOM, where I developed an interest in automation. So now I work as a software engineer at a startup called Join, and we're working on a web-based platform that helps to inform cost-based decisions in the design and pre-construction process. I am also a founding member of the San Francisco Computational Design Institute, or SFCDI for short. We're a group that works to spread the use of computational design tools throughout the AEC industry. Some of the tools that I mentioned today will be available on SFCDI's GitHub page if you want to use them yourselves. So as I mentioned, we're going to be talking about automation. Automation is a topic that really fascinates me. I started learning about automation from an AU class on Dynamo, and then I started learning more by teaching myself Python and using that to write my own Dynamo nodes. And then I started learning C# to write my own Revit add-ins. I was interested in trying out any tool that would allow me to automate my processes so I don't have to do things manually. Luckily, these days there are a lot of tools available to help automate our processes, and we're going to go through some things that can be automated fairly easily. So as I mentioned, we're going to start out with the low-hanging fruit, some things that can be automated fairly easily with existing tools, existing add-ins, or the current state of the Revit API. So what we're going to do is we're going to start off with an AutoCAD file. I think most projects do that nowadays. They start off in AutoCAD and a Rhino or SketchUp model. We're going to take that into Revit. We're going to use that to generate sheets. We're going to annotate that, and then we're going to do some code analysis and then upload the box to share with our consultants. So we're going to look at how each of these processes could potentially be automated. So starting off, we have here a plan of a typical office building. As I mentioned, this project is started in AutoCAD, and we're going to use that, we're going to take that model and use it to generate a Revit model. And thankfully, this process can actually be at least partially automated. So at SFCDI, we created an add-in that can take a imported WDG into a Revit model and parse the layers in that model, and then use it to generate the walls and doors for a model. This add-in is still pretty early on, but it could potentially be used to save a lot of time. It can sometimes take between 1 to 2 weeks to generate a model from an AutoCAD file, and with this you could save huge amounts of time and do it only in a couple minutes. So now that we have a basic model, we still need to fine-tune some things. We need to set the height of the walls, we need to add plumbing fixtures and other objects, but this gives us a good starting point. So in addition to building the model, we also need to set up our datums. And while setting up datums is not a very time-consuming process, it is something that needs to be really accurate. And so automation can help increase the accuracy of this task. So here we have an add-in for a Dynamo node produced by Parametric Monkey that can take an Excel spreadsheet and use it to generate grids and levels in your model. And so this can help increase the accuracy of that task. Additionally, since we have this Excel sheet as kind of the source of truth, we can use that to periodically check that our grid lines and levels are in the right location. I don't know about you, but I have run into several projects whose grid lines have moved, and it's always really alarming because it calls the accuracy of the entire model into question. So this workflow can help increase the accuracy of your models and help reassure you. So now that we have that, we need to start setting up our sheets. Unfortunately, this process can't be entirely automated just yet. It still takes some human know-how to figure out how to lay out your sheets. But once you have a layout, there are tools available to help you automate things. So Ideate Apps has a nice suite of tools that can be used to automate this process. So they have a tool that can take a layout for a sheet. So here we have a plan on our sheet, and we've laid it out in the exact location that we want it. And so Ideate's tool can replicate this layout on all of our other sheets so that the plans line between sheets. It's really a big pet peeve of mine as I'm going through PDFs. I want all the plans to align in the same place. So once we've laid out our sheets, it's time to start annotating them. And the process of annotation is really very tedious, and it's something that nobody wants to do. We oftentimes delegate this to interns, but our interns' time is better spent on other things. So you actually can automate the dimensioning of projects. It's a little bit tricky. At SOM, I was able to develop an add-in that can identify the exterior wall of a building and then use that to generate dimensions. A similar logic can be applied to generate dimensions for the interior of a building. After everything has been dimensioned, we also need to number things. Numbering rooms is a very common task, and also something that's very tedious. There are a number of tools that are available that can help you to number your rooms, and which tool you want to use will depend on how you want to number them. If you just want to number starting from the bottom left and moving to the top right, this is pretty easy to code that logic into a Dynamo script. But what if you wanted something a little more complex? Well, ID8 has another tool called Renumber that can allow you to do this. So here, what you do is you draw a line, and any room that intersects that line will be numbered automatically. So you can see here, we've started in the bottom left, and we've kind of spiraled in towards the center. So as we move from the bottom left to the right, it numbers our first tenant corridor space, 301, and then as we move up, we encounter the stair space, which labels 302, and then as we move back to the left, it labels our next tenant corridor, 303, and so on. So this tool is very flexible, so it can name your spaces using almost any scheme you want. It can have prefixes or suffixes as you need. Additionally, once you've numbered a single level, oftentimes the room numbers are the same between different floors. So 5 through 10 might have the same room numbers, but for a level prefix. So you can actually create a Dynamo script that can take the room numbers from the correct floor and reapply those to the other levels just by swapping out the level prefix. That can save a day or more's worth of work of renumbering rooms. So now that we have that laid out, we need to analyze the code. Code analysis is a big part of an architect's job. It's very important to protect life safety. And it's really exciting that there are a number of tools available now that can help you do this. So a company making one such tool is Upcodes. Upcodes has a Revit add-in that can actually do some preliminary code checking for your building. Now, Upcodes would tell you not to solely rely on this. It's still very early on in development, but it can provide a good first check when you're doing code analysis. So you can see here, I ran Upcodes' Revit add-in on my example project, and it found that my accessible bathroom stall is not actually wide enough to meet code. Additionally, something that's pretty widely done is the analyzation of plumbing fixtures. We all need to have the proper number of plumbing fixtures so that our building meets code. This is also pretty easy to automate because usually the requirements are pretty simple. Once you set up your code diagram area plans, you can use the areas and occupancies from those plans to automatically generate a schedule that shows the required plumbing fixtures. So you can see here, this is what I developed at SOM, is an add-in that can take those code diagram area plans and use it to generate a schedule. You can also schedule the existing plumbing fixtures to compare that with to make sure that you're meeting code. So now that we have the model mostly set up, we need to share it with the consultants. If you're using BIM 360, this process is actually pretty easy because you can automatically publish a model on a regular schedule. But what about those who haven't yet adopted it? So you can also automate this process by using a script like a Bash script or a Python script to upload your model to an FTP site-like box. Such a script is pretty easy to write, and there's an example on SFCDI's GitHub page. You just have to fill in the location of your model, your credentials, and then it can upload for you. And you can use the Windows Task Scheduler to automate this process so that it runs on a regular basis. So that's the process. These are a lot of tasks that can be fairly easily automated, and it can definitely save us a lot of times that we wanted to do things ourselves. So before I end, I want to go through a few more advanced tools that can allow us to automate a lot more and save a lot more time. These next tools, though, do require a little bit more setup in order to start using. The first tool I want to mention is Clarity. Clarity is produced by Imagine It, and it's a tool that allows you to autonomously run tasks on a Revit model. That means that I can run a task on my model without actually having to open up Revit myself. And you can also schedule tasks or run them on demand. It has a number of built-in tasks like printing PDFs, exporting DWGs, uploading consultant models, and so forth. It can also run tasks on Dynamo nodes or custom plugins so that it can automate almost anything. I've used this a lot at SOM, and it saved me huge amounts of time, especially in replacing consultant models, amongst other things. Another one I want to mention is Speckle. Speckle is very similar to Flux, for those of you who remember that. It's an open source tool that allows you to transfer geometry between platforms. So Flux, you can use it to transfer Rhino geometry from one session of Rhino to another if you wanted to share your working model with a consultant, or you can use it to transfer geometry from Rhino to Revit directly. Since a lot of firms oftentimes design in Rhino, this is a great tool to be able to work more easily with your design teams. The next tool is something that is a little bit more advanced. This is kind of something that gives us a hint of what the future can hold. So this is a space planning tool that uses an AI-based algorithm to generate a space plan for a building. So you feed it an Excel spreadsheet of spaces and their adjacency requirements, and then you tell it the exterior shape of the building, and from that, it can generate a space plan for your building. Now this is currently a Grasshopper script, so to use that with Revit, you'd have to either export it and import it into Revit, or you could use Speckle to transfer it over, or you could use Rhino inside to embed Grasshopper directly into Revit. And so I'd like to end with a quote from Arthur C. Clarke, who wrote that any sufficiently advanced technology is indistinguishable from magic. And advanced technology is like magic to me, not because I can't understand it, but because of the amazing things that it makes possible. Automation is magical to me in that it can do so much more than I ever did before. And I invite everybody here to try out these workflows and experience the magic for yourselves. Thank you.